dew point temperature is close to the dry air temperature, the relative humidity is high. Okay. If the dew point is well below the dry air temperature, the relative humidity is low. Okay, so relate to the amount of water vapor is presence or contained in that particular atmospheric air. And dew point temperature is always lower than the dry bulk temperature and will be identical with 100% relative humidity. Okay. The air is not the saturation line. As the air temperature changes, the dew point tends to remain constant unless water is added or removed from the air. Okay. So dew point is important if, for example, you are using air conditioning process that want to cool down a volume of air, but you don't want to encourage the generation of liquid. You don't want the water to transform from water to liquid. Because maybe, for example, your application concerns about ensuring cool conditions, but you don't want to have any liquid water everywhere. Especially if you are dealing with cooling a specific or sensitive equipment, you want to create a cool surrounding, but you don't want to have water as a liquid presence everywhere in the corner of the room, beside the boxes, or maybe underneath your equipment or facilities and so on. Okay, so that's why we monitor the dew point temperature, because we want to prevent the atmospheric air to reach the saturation level. Another way to understand the dew point temperature is the temperature at which condensation begins when the air is cooled at constant pressure. So if you have a TS diagram, so at constant pressure you cool down the air, it will reach this line here at the dome. Okay, you know that once the air reach this dome, because here you have a mixture, bawah dome tu ada kandungan campuran udara dan peruap air. The moment you touch, which means that the water vapor exists, the water vapor and liquid exists at the same time. Okay, because here is compressed liquid line. Compressed liquid is superheated. So at this particular point, so you maybe have 99% exists as a water vapor. Okay, kalau dalam table G lah. And maybe you have 0.1%, only 1% present as liquid. Okay, the moment you touch this temperature, liquid appears, then it's what we call as the dew point temperature. Okay, you take your cool or cold drinks from your refrigerator or from your vending machine. The moment you put it at the atmosphere, so it starts to condense. Okay, so, or we call it the sweats start to appear. Okay, liquid water is we call it visible, or because of the condensation. So we call it liquid water droplets. Dalam bahasa Melayu, dew ni it's embun lah. So if you wake up early in the morning, 6 o'clock or maybe around 6 to 7:30 in the morning, if you touch the leaves on the trees or pohon dan ada rasa basah, sebabkan dia embun tu, bermaksud suhu pada masa tu ialah suhu pembentukan embun ataupun dew point temperature. So we want to monitor this because like I said, in certain engineering applications, you don't want to have the droplets to appear. The facilities or the machines and so on. Okay? But at the same time, you want to cool down. Because you're dealing with cooling, you want to reduce the temperature. But you need to be aware. When you're dealing with atmospheric air, dan kita nak sejuk. Tapi kalau suhu tu jatuh cecah nilai condensations, kita masih dapat sejuk, tapi pada masa yang sama kita akan terima cecair ataupun air dalam bentuk cecair yang mungkin macam tadi lah membahayakan kita punya operasi ataupun keperluan dan sebagainya. Okay. So based on the conservation of mass, okay, so we know that the mass flow rate of dry air remain constant, okay, and the mass flow rate of vapor in the air increased by an equal amount to the rate of evaporations. Okay, because air remains the same. So what you control is the presence of water vapor. So you can rearrange those based on the humidity ratio equations. So the dua humidity ratio ataupun specific humidity, satu lagi ialah specific humidity, satu lagi ialah nilai phi, phi ialah nilai relative humidity. The specific humidity and the relative humidity of air can be determined from those equations here, and you can measure the pressure and temperature, and you can determine what will be the amount of humidity in that process. So adiabatic means that we assume that everything is happening without any heat transfer to the surrounding. Okay, unsaturated air, saturated air, so your relative humidity is very high. Okay, so these are the conditions involved. The adiabatic saturation process is not practical, so a more practical approach is to use the thermometer whose bulb is covered with cotton wick. Okay, like I explained just now. And then the temperature measure is the wet bulb temperature, commonly used for the air conditioning system. Okay, and the air water vapor mixture at atmospheric pressure is approximately equal to the adiabatic saturation temperature. So we use that assumption in terms of physical measurement. So this is what we call the wet bulb temperature reading, and this is the dry bulb. Okay. Okay, before we finish for today, the psychometric chart present the moist air properties in a convenient form. And if you are into the air conditioning industry, so you really use this as your guide, as a tool to measure, because the air conditioning unit, or what we call this the split unit or aircon in the common term, we are dealing with the removal of the moistures. Okay. So by controlling the presence of moisture, then we can provide the comforts to the humans or to the subjects that require the air conditioning process. Do not mistaken that we use the air conditioning simply to reduce the temperature. The temperature reduction that we chose using the remote control is just the process to the surface process to control the amount of moistures. Okay, because it's much more practical to show to the users in terms of the temperature reading. But from the engineering perspective, we're talking about controlling the presence of the water vapor. Okay. When we read the psychometric chart, so the vertical axis is specific humidity, and then you have such a line here. Okay. Phi, or the relative humidity. So relative humidity is this line here, diagonal line is relative humidity. And then we have the wet bulb temperature. Okay, and then the vertical line, the vertical axis, the horizontal line is specific humidity. Horizontal axis and the vertical lines are the dry bulb temperature. Okay, so this is the sketch for the psychometric chart. So if you reach this saturation line, for example, here the saturation condition, the temperature is 15 degrees Celsius. So basically, this is the dew point temperature, and this is also the wet bulb temperature. and this is also the dry bulk temperature. Okay. If the condition is what we call it saturated air, so we reach here. So ada banyak lagi lah saturation line. Kalau bertemu, then we call it the saturation line. Then we can see that all the three temperatures are identical. Okay, I've shown you this before. So you use this to read this. Okay. Kita tengok betul-betul lah garis ni. So ni adalah vapor temperature. Okay. Yang ni adalah dry bulk yang menegak. This is your relative humidity. Okay, which is also the parameter to define the saturation conditions. Okay. And then here is your specific humidity line. Okay. So ni lagi tunjuk lain ada. So ni lah garis ada. For this example, the working temperature units is imperial, which is Fahrenheit. There are also different type of psychometric charts which use the same metric units. Okay, briefly on the human comfort and air conditioning. So why we call it air conditioning? Because we want to make sure that we can transfer the heat to the surrounding, so a body feels comfortable when it can dissipate its waste heat no more. Okay, the moment you are able to dissipate the heat from your body, then it's where you start to feel comfortable. Okay, the comfort of human body depends on three factors: the dry bulk, relative humidity, and also the air motion. So if you have installed in your room a fan on top of your air conditioning, then you will be faster for you to experience the coolness or the comfort level that you set upon. Relative humidity affects the amount of heat a body can dissipate, and most people prefer relative humidity of around 40 to 60%. Okay. As the air motions remove the warm, moist air build up around body and then replace with fresh air. Okay, so this is how we condition the air to the comforts of the human's behavior. Okay, so I think I'll stop there. So stop the recording. Okay. All right, so that's all from me.